Okay, guys, we're trying to prove this one is irrational by contradiction.
So assume this is rational.
So assume column this is rational. So
Yes.
if it is rational, then must be it is like this, P by Q, right?
Yes.
Where P comma Q belongs to natural numbers. Am I right?
And there have no common
Yes, and they
factor.
have no common.
PQ belongs to natural numbers. Q,
And P are integers and have no common.
P and Q not equal and not equal to 0. Am I right?
Yes,
And
sir.
third one is P and Q does not have,
Common number.
do not have common factor. So what's wrong with this? If we assume this,
এটা
Yes,
ভায়োলেট
sir.
করলো না স্যার ওইখানে
Oh,
স্যার এখন স্যার আমি তো এখানে প্রুফ
which
করেছিলাম
one has been violated? Which one has been violated here?
hasn't been লাস্টেও তো স্যার কমন ফ্যাক্টর পেলাম না স্যার
জি স্যার লাস্টে তো কমন ফ্যাক্টর পেলাম না স্যার তো এটা তো রেশনাল প্রুফ হয়ে গেল তাহলে
কমন ফ্যাক্টর পেলাম না কিন্তু এই দুটো তো সমান হওয়ার কোনো স্কোপ নাই এ আর বি তো ডিফারেন্ট নাম্বার এ এন্ড বি আর ডিফারেন্ট নাম্বার তাহলে এই দুটো সমান হয় কিভাবে আমার লজিক্যাল ফ্যালাসি বিকজ দে ক্যান নট বি ইকুয়াল নট বিকজ অফ কমন ফ্যাক্টর হিয়ার if a and b are different natural numbers, can a to the power b equal to b to the power q? Is it possible?
নো
So there is a fallacy problem. This problem does not arise because of there is no common factor. Here it arises because this is not equal. Did you get it or not?
ইয়েস
And cano it is not equal because they don't have any common factor. Did you get it or not?
ইয়েস
মনে করেন 3 a equal to 3 b equal to 5. Can you raise a to the power something and b to the power something to make this two equal? Is it possible?
নো স্যার
If you made if a equal to 3 and b equal to 5, if you raise 3 to the power p and 5 to the power q, can they ever be equal?
নো
Why not they can be equal?
So common factor.
They don't have any common factor. It's the সম্পূর্ণ multiplication of 5. This is completely multiplication of 3. They don't have common factor, so we cannot reduce it. We cannot reduce it, but they are equal. So it's a problem. Am I right or not?
স্যার এখান তো
Right.
কমন ফ্যাক্টর নাই তাহলে কি রেশনাল প্রুফ হয় না স্যার মানে কন্ট্রাডিকশনে তো আমরা এরকম কিছু একটা করেছিলাম স্যার
হ্যাঁ কন্ট্রাডিকশন এটা কিছু করেছিলাম এটা অন্য প্রুফ ছিল এখানে কমন ফ্যাক্টর নাই ঠিক আছে কিন্তু ইকুয়াল তো কখনো হতে পারে না ক্যান দে বি ইকুয়াল
নো
the question is about equality. The problem arises because of the equality, not because of only common factor. They don't have common factor. Am I right or not?
ইয়েস স্যার
3 to the power p and 5 to the power q, can they ever be equal?
নো
Why not? Because they don't have any common factor. On the left side, there is only 3 to the power something. So it is 3, 3, 3, 3, 3. On the other hand, on the right hand side, only 5, 5, 5, 5, 5. So you cannot reduce anything. You cannot reduce anything. So right hand side is divisible by it contains b. It contains b. And I never say they don't have common factor. That's why there is a problem. I say the right hand side we have b. On the left hand side we don't have b. So that is the problem. So definitely right side and left side are not equal. Is it clear or not?
yes
ইয়েস স্যার
Right side, there is a multiplication of b. On the left side, there is no multiplication of b. Can they ever be equal?
no sir
Simple. That is the reason of problem. Did you get it?
yes yes sir.
Did you get it?
yes sir
ইয়েস স্যার
Let's example. Let's say 3m equal to 5m. Can then be equal? Can they ever be equal? Can they be equal?
so possible যদি n
It is
equals
possible.
5
It is possible. It is divisible by 3. 5 is not divisible by 3. But if 3 is divisible by 5, then they might be equal. Am I right?
yes sir
then n becomes 5m by 3. It is possible. But let's say 3 to the power p and 5 to the power q. This is divisible by 3. And this one is not divisible by 3. Am I right?
Yes.
So can they be equal? Left side is divisible by 3 and right side is not divisible by 3, but still they are equal. And both are integers. Are they possible?
No.
So that is the case. That is the case. That's the fallacy. That's the problem. Did you get it? Here the problem arises not because of they don't have common factor. Here the problem arises as they are equal, but one is divisible by b, another one is not divisible by b. Did you get it?
Yes, sir.
Okay, so let's move to next problem. Let's start to this. Yes.
আরেকটা কোশ্চেন ছিল স্যার নাম্বার 8
Yes. What's wrong?
the question is স্যার বলা যে 1 mod 3
1 mod 3. Yes.
স্যার সলিউশনটাতে স্যার নাম্বার 2 তে যেটা ফাইনাল স্টেট স্যার তখন কি স্যার টোটাল 2 হচ্ছে
আমি কোনটাতে সার্কেল করেছি
নাম্বার 2 তে স্যার
Let's good go. Let's go. Wait a minute, please. Number 2, right?
Number 8
Number 8. Yes.
এখানে কি স্যার
Oh, it is wrong. It is wrong. Yes, it is wrong.
One is
it should be middle one. Yes. If it is mod 1,
back করব
right. So I'm going to correct that one. Don't worry. Okay. So should we start today's class?
Yes, sir.
And this problem is clear to you, right? Right side is divisible by some now integer b. Left side is not divisible by some integer b. So they can never be equal because both are integer. Am I right?
yes sir
Okay, so let's start today's class. All right, guys, so let's start. So what is finite automata? What is finite automata? What is finite automata?
Algorithm to solve a problem.
Yes, sir. The machine implementation of an algorithm to solve a problem. Now, what is called finite?
so limited sir
Limited what?
Limited element.
Number of states. Number of states. Number of states are finite. That's why it is called finite automata. Okay? It cannot have infinite number of states. That's why it is finite. Okay? So how can we represent finite automata? Using Q, which is number of states, sigma, Q, which is set of states, sigma, which is actually input alphabet, delta, Q naught, and F. So Q is set of states. Sigma is alphabet, delta is transition, Q naught is the start state, F is the final state. What is deterministic finite automata? What is deterministic finite automata or DFA? What is the definition of DFA? All things are same. This one same, this one same, this one same, this one same. Only there is a difference on delta. Delta is a function. And how can we define this function? This function is nothing but Q cross sigma to Q. Did you get it? Right?
Yes.
Yes, sir.
So this one is my domain of the function. This one is my codomain. So this is the function. In terms of finite automata, what is the definition of this delta? In terms of finite automata, what is the definition of this delta in DFA? Each state should have only one move on all the letters in alphabet. Is it clear to you guys? Each state should have only one move on all the letters in alphabet. Done? Is it clear
Yes.
to you guys?
Yes,
Okay.
sir.
So let's take some problems and try to solve those. Let's take my sigma is A comma B. My language is all strings length greater than or equal to 3. So how can I solve this problem? How can I solve this problem? Sigma is A comma B, L is all strings length greater or equal to 3. How can I do
থ্রি
that?
পর্যন্ত যাবো স্যার, থ্রি পর্যন্ত যাবো।
What would be the algorithm? What would
স্টার্ট
be the
স্টার্ট করবো এ বি, আরেকটা নোড, আরেকটা
no? Tell me the algorithm. What would be the algorithm? General procedure to solve this problem. I should have one state which is going to accept length 0, right? I should another state which is going to accept length 1, another state length 2, another state length 3, another state length 4, another state length, let's assume greater or equal to 4. Okay? So I should start from this one, the initial state, because this is the length 0, epsilon state. Then after seeing, so by the way, what would be inside this language? What are the strings inside this language? What is the list string inside here?
ট্রিপল এস,
Is epsilon
ট্রিপল এস,
Why? Greater or equal to 3?
past
Triple
greater.
Greater or equal to 3?
ট্রিপল এস স্যার, ট্রিপল
So list one should be 3, length 3. So A, then A, B, A, so on. Is it finite or infinite, the language?
Sir, infinite.
Because I'm going to
Infinite.
accept length 4 also, length 5 also, length 6 also, length 7 also. This way I'm going to take all the length greater than 3. So the language would be infinite. So in length 0, if I get A or B, what would be my length?
ওয়ান স্যার,
1. Then if I get another A or B, what would be my length?
টু,
If I get another one, my length is 3. If I get another A or B, my length is 4. If I get another one, length 5, length 4, then if I loop here, I will continue length greater or equal to 4. Am I right? Am I right or not?
ইয়েস স্যার।
Now, what would be my final states? Length 3 is must my final states because equal there. Length 4 is also my final state. Length 4 and greater. Let's make it length 5 and greater. This is length 5 and greater. So this one is also my final state. Is it a DFA?
Yes, sir.
Is it a DFA?
Yes, sir.
So what is the definition? Each state should have only one move on all the letters in the alphabet. So in my alphabet, there is A, B. This state has only one move on A and only one move on B. So over the alphabet. This state has only one move on A, one move on B. So this is done. This is done. This one is also has one move on A, comma B. This one is A, comma B. This one is A, comma B. This one is A. So is it a correct DFA or not of this problem?
Yes, sir. Sir, আমরা কি স্যার 4A শেষ করতে পারতাম?
Wait, আসছে। But can we minimize this? Is it possible to minimize? Instead of writing this state length 3, we can write it greater or equal to 3. Am I right? Then if I loop over here, then we can actually discard this one. Am I right or not?
Yes, sir.
3 is the final state.
So this one is no longer length 3. This one is length 3 and greater. So just making this one final state and loop over it, we can discard other. So is it also a correct DFA or not?
Right, sir.
Yes, sir.
It is also right. So the thing is, for a single problem, there might have multiple DFS. But it is better to always draw the minimum DFA. Minimum DFA has minimal state to solve that problem. Okay, guys? Do you have any more query? So this is the minimal DFA. We need at least 4 states. Done?
Yes, sir.
Okay, so let's move to next one. You people are always getting confused with one concept, so let me discuss that. Okay, always you people getting confused, so let me remind you again and again, so that you people are getting very familiar with this one. A string accepted by a DFA. What is the meaning of this? A string accepted by a DFA. What is the meaning of this?
State
String belongs to L.
Wonderful, sir. Traversing the DFA from start state with string leads to a what?
Leads to one of the
To a final state. Right. A string rejected by a DFA. What is the meaning of this? What is the meaning of this?
It doesn't reach the finals.
Does not reach the final state. Now, a language is accepted by a final automata. What is the meaning of this? What is the meaning of this? It is the $1 million question.
Sir,
All
Language-
belongs to language.
All strings
inside language.
belongs to language, then
Accepted by Finite Automata.
accepted by. Is that all?
So, and all strings that does not belong
Yes,
to language
that is very important.
is rejected.
Very
Rejected by Finite Automata.
all string not belongs to language is rejected. That is equally important, because we know that if we draw this finite automata, it is going to accept any string. Any string possible over sigma a comma b. Am I right? That does not mean it is actually correct finite automata for any language. Am I right? Why not? Because it is also going to accept some string which does not belong to language. For example, language, let's say my language is A, A, B, B, A. Yes, definitely all these strings are accepted by this finite automata, but rest of the strings which does not belong to language are also accepted by this finite automata. They are not rejected. So that's why it is not a correct DFA. Am I right or not?
Yes, sir.
Okay, sir. So let's do some problems more. Let's go to problem 2. I've already did this one. Still I'm doing it. All strings ends with B. How can you solve this one? What would be my algorithm? And what would be the first member in the string?
So B.
B, sir.
B, then
AB,
then
Double B.
BB,
then
Then check A, B.
A, B, A, B, B, so on. Finite or infinite?
Infinite.
Infinite.
Infinite. So what would be the, now tell me, what would be the algorithm? How can I solve this problem? What would be the algorithm?
So একটা start করবো, sir.
What would be the algorithm? How can you solve this problem?
A হলে স্যার একটা দিব আর
So
B হলে
algorithm হচ্ছে number 1. If starts with A, then what happens? It starts with A, then
ফাইনাল স্টেটে যাবে না।
so
we need to find B, sir.
we will wait for B. We will wait for B, right?
Yes.
Number 2, if we starts with B, then what happen?
Then
Consider
it will go in final.
it as last B, right? Last B or ending B. Am I right?
Yes, sir.
Therefore, if I again get B, what happen? Then what happen? If I again get B, then what will
Continue
do?
to loop. Continue to loop.
In which state? Which state? The final state.
Final state.
So if we again get B, we consider it ending B and remain final state. আর যদি এখানে আমি আবার A পাই, then if get A, then what happen?
এর তো কোনো হিসাবই থাকবে না স্যার, ফাইনাল স্টেটেই থাকবে।
Final state থাকবে, তাহলে ending with B হলো কিভাবে? Something like this. Let's assume A, B, B, suddenly I get A. If I still in final state, does it end with B?
No, sir.
No,
That's
sir.
reject.
So we have to search for another B.
So we have to search for another B. So which state I should go if I get another A? We'll start again to start state because I'm expecting another B here. Is it clear to you?
Yes, sir.
Returns to final because in this state, start states, we are looking for a B. Am I right? In the start state, we are looking for a B. So after getting to final state, if I get a A, I should return back to start state so that I can get a B. Am I right? Come on. So it is something like this. starting from here, if I get a, I'm waiting for B. Am I right? If I get a B, I will consider this is the ending B. Am I right?
Yes.
Yes, sir.
If I get more B, still I am ending with B. So I will remain in the final state. Am I right?
Yes, sir.
Here, if I get a, so I have to looking for B, ending B. So I will come back here again,
Final, yeah.
initial state.
Yes, sir.
So this is the finite automata. Am I right?
Yes, sir.
Okay, sir. If this is true, how can you solve this one? My sigma is 0, 1. My language is all binary numbers, all binary even numbers. So how can you solve this problem? How can you classify binary even numbers? What is the specialty about binary even numbers? How can you find out a binary number is even? Tell me. Is it a binary number? 1, 1?
Yes.
Sir,
Is it,
binary number.
is it even or odd?
Sir, even, sir.
So
It is even. It is actually odd. Its value is 3.
So
It is
last
actually
is the
decimal.
Sorry, sir. Sorry, sir.
The last one.
If I rate 110, if I rate 110, then actually it is even. It is even. Its value is what? 246.
Sir.
So it is
Six,
even.
sir.
So how can I find out a binary number is even or not?
So last is the zero.
last is zero.
Okay. So last digit is 0 থাকে তাহলে even. তাহলে আমি কিভাবে, how can I find all the binary even numbers? Using this one. Using this one. Yes, আগেরটার মতো.
So all the
B-
strings that end with 0.
Wait, yes, all the strings ends with 0 because we can consider B is nothing but 0, A is nothing but 1. Am I right?
Yes, sir.
So what would be the
100.
final? So what would be the final automata? Something like this. If I get 1, I will wait. If I get 0, then I will reach to final state. Then again 0, I will remain there. Finally get 1. Got it? The same solution. Do you have any query? Now, my question is, how can you prove that if the last digit is 0, it is actually even number? If a binary number last digit is 0, it is an even number. How can you prove that? Proof. Without proof, nothing is valid. Bhuya Sadman Wasif, how can you prove? How can you prove if the last number is 0, it is a even number? So let's try to prove that. If we write 1101111, what is the decimal equivalent of this? How can you find the decimal equivalent?
It is a 1248.
It is 0, position is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Am I right?
Yes, sir.
right? It is nothing but 1 into 2 to the power 7 plus 6 into 2 to the power 6 plus 0 into 2 to the power 5 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 0 into 2 square plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. Is there any shorter method? Is there any shorter method? What is 1? Binary 1? What is the equivalent decimal?
So 1,
If I write 1 0, what is the
2, sir, 2.
2? So can we write this way? This one is 1 decimal. So it is nothing but 1 into 2 plus 0. Can we write this way?
Yes, sir.
Then 101. What is the equivalent? We know that this one
It's the
is
5.
decimal equivalent 2. So 2 into 2 plus 1 equal to 5. Can we continue this way? Then if we write 1011, this one up to this, just before last digit, this one is decimal equivalent 5. So this one is, the whole thing is 5 into 2 plus 1 is equal to 11. Can we write this way? Can we write
Yes.
this way? Is it correct or not?
Yes, sir.
Then if we put another one, 10110, we know that this one is 11D. Am I right? So the whole thing is 11 into 2 plus 0, but 22. Am I right?
All right, sir. Even so 2 এর multiple আছে, so এই পার্টটা even plus.
Yes, yes, yes. Now, how can I prove the last digit is 0? Then it's an even number. Let's say 110111 0. So this whole thing, decimal equivalent of whole thing should be multiplied by 2 plus 0. So definitely this is divisible by 2. Am I right?
Yes, sir.
Yes, sir.
Then whole added 0, then whole thing should be divisible by 2. Am I right?
Yes, sir.
So definitely it is actually even number. Am I right?
Yes, sir.
So last digit is 0, then it would be all right. So there are different number systems there. There are binary number system, ternary number system, octal number system, hexadecimal number system, then ternary number system. So you can apply this formula again and again. So remember, in binary case, what are my symbols? Symbols are
0, 1.
0 and 1, and my base is 2. In ternary system, that's it. As the base is 2, we always multiply by 2. Right? In ternary, what are my symbols? What are my symbols? 0, 1, 2. My base is actually 3. Did you get it? So in that case, if you want to convert it to equivalent decimal, from ternary to decimal, you have to multiply with 3. Got it?
Yes, sir.
Yes, sir.
Okay. Now let's do a very important one. So how can you solve this problem? all binary numbers congruent to 1 mod 3. That means whenever you divide all binary numbers with 3, the remainder should be 1. So how can you accept this like this? How can we accept this like this? At first tell me, how many states would be there? How many states would be there in the finite automata? Mod 3. So all numbers mod 3. What are the possibilities? Come on.
Sir, 1 থেকে start.
1 1
Sir,
forget
less
about
than 3, greater than
1
3.
0.
if I did mod operation, then how many possibilities are there? What would be the answer for mod operation 3? When we mod some numbers, what would be the range of the output?
0 to 2, sir.
0 to 2. So remainder 0, remainder 1, remainder 2. So how many states should be there? 3 states, right? So 1, 2, 3. Remainder 0, remainder 1, remainder 2. All right? Initially, let's say 0. Then what would be the remainder? 0 is nothing but 0 in decimal. So what would be the remainder? 0 remainder 3 is what? Come on,
That
guys.
would be 0, sir.
That would be 0. So I would be in this state. If I get more 0, 0 to 0, what would be my remainder?
Loop, sir.
Still 0. So if I get remainder 0 state, if I get 0, still I would be in same state. Did you get it?
Yes, sir.
Now, after getting 0, if I get a 1, then my number would be 0, 1, which is nothing but decimal equivalent of 1. So what would be my new remainder?
1, sir.
So which state I should go?
Reminder 1 state.
So after getting 1, I should go over here. After getting 1, yeah, if I get another 0, then my new number is 1, 0, which decimal equivalent is
It's
2.
2, sir.
sir.
So which state I should go?
Reminder 2 state.
So remainder
Remainder
2.
2. So after this state, if I get 0, I should go to remainder 2. On the other hand, after getting 1, if I get another 1, my new 1 is 1, 1, which is
Becomes
nothing
3.
but decimal equivalent 3, which is mod divided by 3 equal to 0. So which state I should come?
Back to
Back to
reminder
origin.
Initial
Back to origin. So I'm done with this state because 0 and 1 both move are there. I'm done with this state because this is 1. 0 and 1 are in this state. So I have remained this one. In this state, it is nothing but after getting 1 and 0. 1 and 0. If I get another 0, then the number would be 1, 0, 0. What is the decimal equivalent for this? 0 to 4.
4.
So if I remind with,
That would
if
be
I
1.
mod with 3, then that could be 1. So I'm returning back to remainder 1 state. And if I get in this state 1, the number is 101, which is nothing but 5
5,
decimal.
that would be reminder 2.
So
Same thing.
remainder 2, I will remain in the same state. Now, what would be my final state here? What would be my final state here?
Reminder 1. Sir.
Remainder. So this one is my final state. Did you get it? So this is the solution. Is this problem clear to you guys? If you have any question, you can ask me.
Sir, remainder 1 final state channel.
1 mod 3. This one is nothing but, this one is nothing but number mod 3 equal to 1. Same thing. Same meaning. Is it clear to you?
Yes, sir.
Okay. So let's go to problem 5. How about other guys? Why other people are not saying anything? Tarek Aziz, what happened? Tarek Aziz? দেখি গার্লসদের কি অবস্থা? আমার এই ক্লাসে গার্লস নাই। কথা আছে না, কান টানলে মাথা নেই, সেরকম একটা ব্যাপার আছে। মেরুন্নেসা মতিন, মেরুন্নেসা, মেরুন্নেসা,
Yes, sir.
what happened? Why you people are not participating? Only three, 4 students are participating. The entire class. What are you doing actually right now?
Sir, I'm taking notes and understanding.
Then why don't you asking question then? You understand everything?
Yes, sir.
You understand everything? Okay, fine. Let's go back to Julkan 9. Julkan 9? Julkan 9?
Yes, sir.
Why don't you asking question?
বুঝতেছি স্যার।
বুঝতেছেন? আচ্ছা, বুঝলে ভালো। কোশ্চেন কিন্তু আমি বললাম এমসিকিউ টাইপ হবে, একটা ভালোই টাফ আসবে। আমি I'll put 4 questions very easy, 2 medium, 1 is moderately hard, 2 is hard, 1 is very hard. I do not want to fail anybody, so I'll give 4 questions very easy. If you participate in my class, definitely you can answer 6 questions. But if you don't participate in the class, it is up to you. Is it clear to you guys?
Yes, sir.
Merunasa, is it clear? Is it clear, Merunasa?
Yes, sir. Yes, sir.
Okay. I'm trying to helping you. Never say I'm not trying to helping you. I think I never want my students getting F grade. But if you don't participate in my class, I can do nothing. Simple. Okay, go back to study.
স্যার আমাদের সবগুলো কোশ্চেনই কি স্যার এমসিকিউ হবে?
সব কোশ্চেন এমসিকিউ হবে, ওটা নিয়ে আমরা ডিটেইল আলোচনা করব পরে, ডোন্ট ওয়ারি। আগে সিস্টেম, let me back. হ্যাঁ, প্রবলেম সলভিং।
স্যার প্রবলেম 4টাকে আরেকবার একটু বোঝানো যায়?
তখন আপনি প্রশ্নটা করেন নাই কেন? তখন why don't you ask that question when I just finished or I am just solving the problem 4? Is there anybody who can make her understand problem 4? Is there anybody who can make her understand problem 4? Anybody? So let's go back again. এই জন্যই তো সাদমান ওয়াসিফ,
জি স্যার।
কান টানলে মাথা আসে, এই কথাটা বুঝলেন তো কেন বলছি? পরীক্ষার কথা বলার পর সবাইকে এরকম পাখির মতো কলরব তুললো, দেখলেন তো? পরীক্ষার কথা বলার সাথে সবাই পাখির মতো কলরব তোলা শুরু করলো। এইটাই জগতের নিয়ম আসলে, পরীক্ষা দরকারি। Let's go back to the point again. So my alphabet is 0,1. Language is all binary numbers congruent to 1 mod 3. That means that number divisible by that number when we divide by 3 creates remainder of 1. So this is the remainder. So let's start from this state. So as all the mod operation have 0 up to 1 minus that number. So in this case, mod 3 has remainder 0, remainder 1, remainder 2. 0 up to 1 minus that number. So 3 minus 1 is 2. So remainder 0, remainder 1, and remainder 2. So in my DFA, there will be 3 states. Remainder 0, remainder 1, and remainder 2. Okay, so we start from the start state, and that is my epsilon state. So initially, if I get a 0, then decimal equivalent of this binary 0 is nothing but 0. And 0 mod 3 is nothing but 0. So I should remain in this state. If I get more 0, 0, again 0, then it becomes 0, 0, which is nothing but 0 in decimal Again, if we mod 3, we get 0. So we should remain in the remainder 0 state. On the other hand, after getting 0, if I get a 1, my new number would be 0, 1, which is nothing but 1 in decimal. If we mod 3, we get 1. So after getting 1, we should go to state number remainder 1. Then, after getting 1, if I get a 0, my new number is 1, 0. What is the decimal equivalent of 1, 0?
2.
What is the decimal? 2. So if we divide 2 by 3, we get remainder 2. So from remainder 1, after getting 0, I should go to remainder 2 state. On the other hand, after 1, that means in remainder 1 state, if I get a 1, my number is 1, 1, which is nothing but 3 in decimal. If we divide by 3, the remainder is 0. So I go back to remainder 0 state. So this is done, this is done. We left only this one. In this state, after getting 1 and 0, we reach to this state. So if I get another 0, the number becomes 1, 0, 0, which is nothing but 4 in decimal. So if I divide it by 3, the remainder will be 1. So I would come back to remainder 1 state. On the other hand, 1, 0, after getting 1, the number is 1, 0, 1, which is nothing but 5 in decimal. If we divide by 3, it is nothing but remainder 2. So we'll keep in the remainder 2 state. Is it clear to you?
Yes, sir.
Okay. So remember, let's give you some tricks. Drawing final state machine is very easy. Drawing final state machine is very easy. You have to come up with algorithm, try to find a skeleton, that means a string inside the language, which is very authentic. Try to find that one. Then actually draw finite automata for the skeleton, then make the makeup. Then you people are done. I did the same thing. I take skeleton as 1, 0, then I make up. Did you get it?
Yes, sir.
Okay, so what is this called actually? What is this diagram called? This is called
Transition.
state transition diagram. In another way, we can represent finite automata. That is called state transition table. So instead of drawing diagram, we are going to draw table. We are going to draw table instead of drawing diagram. So what would be that table? The table would be like this. Let's try to draw a table for this one. Let's call this state A, call this state B, let's call this state C. So by the way, actually, what is representing in the state transition diagram? Can you tell me? What is actually representing here? What is it is representing? Out of this quintuple, which one is actually representing here? Which one is representing in the state transition diagram? What do you think? Which one is representing?
The function.
The delta. It is the detail visualization of delta. So same thing. It's state transition table. We are representing delta in a tabular form. So how can we represent delta in a tabular form? Very easy. It is very easy. So we are going to draw a table like this. In the leftmost column, we'll put all the states. In this case, it is nothing but ABC. Okay? Start state, we put an arrow here. Final state, we put a star here. Okay? And on the topmost row, we'll write the letters in the alphabet, which is nothing but 0 and 1. Then we'll fill up these entries for the transition function. A seeing 0, why should it go?
A, sir. A.
A seeing 1, why should it go?
B.
B seeing 0, why should it go? C. B seeing 1, why should it go? A. C seeing 0, why should it go? B. C seeing 1 should go C. So done. So this is the state transition table. The same. These two are same representation, and actually they are representing the transition function. True, but it is always preferred to draw state transition diagram in finite automata course, because this is the standard norms to represent finite automata this way. All right, guys. Do you have any more question? No question?
স্যার আমাদের
Yes.
যদি স্টেট ট্রানজিশন ডায়াগ্রামটা ড্র করতে বলে তাহলে তো আমরা স্টেট ট্রানজিশন টেবিলের দরকার নেই, কারণ আমাদের ইভেন্চুয়ালি ডায়াগ্রামটা ড্র করতে হবে।
Yes, yes. Those are alternatives. I have already pointed out. Those are alternatives. You are right. Those are alternatives. You do not need to do both. Of course not. Any more question? Should we continue to next problem? Okay. Let's go to problem 5. My sigma is 0, 1. My language is all strings. Even number of 0, odd number of 1. So how can I draw this? All strings, even number of 0 and odd number of 1. Tell me this. How can I draw this? So think this way. At first, try to come up with algorithm. Before it, let's tell me some of the strings. What are the language? What are the strings inside the language? Even number of 0, odd number of 1.
Sir, 0.
0 means that is odd number of 0. So it should not be.
1,
1. Okay. Then
0, 0.
0, 0. Then
001.
0, 0, 1. Yes. Because if you say 0, 0, the number of 1 is 0. That means it is even. So it cannot be. 0, 0, 1 is fine. Any more? Anything more?
Sir, 00111.
How about 401? Is it correct?
Yes.
How about this? 111?
Yes, sir.
No, sir.
All fair. Okay. 00111.
Yes.
Odd.
Yes, sir.
Yes, sir. So this way it will continue. Infinite or finite?
Finite, sir.
Infinite. Okay. What would be the algorithm? Not tell me.
স্যার দুইটা স্টেট থাকবে অড ইভেন
দুটো স্টেট থাকবে for what? For which one?
one for even, one for odd.
Which one? Which one? Which one are you talking about?
Odd.
আমরা তো
Even
দুইটা
for 0,
we are not counting the total number of 0 and 1. We are counting 0 individually, 1 individually.
Sir,
And
one
which-
is a state for 1 and one is a state for 0.
Wonderful. So number of 0, one in one place we have number of 0, another place number of 1. So number of 0 can be even or odd. Number of 1 can be even
Even or odd.
odd. Now how many states in the how many states would be in the finite automata? If number of 0 is even, still I have number of 1 even and odd. So if the first one is 0 and second one is for 1, then one state might be EE, another state might be EO. Am I right?
Yes, sir.
नीचे line. EO. Am I right?
Yes, sir.
Now, if you take this one odd, I have one state is OE, another state is OO. Do you agree with me or not? Where this one means 0 even, 1 even. Here it means 0 odd, 1 even. This one means 0 even, 1 odd. This one means 0 odd, 1 odd. Because first one is 0, second one is 1. Is it clear to you?
Yes, sir.
We should have 4 states. Initially, epsilon means 0 even, 0 odd. So it is E. Am I right or not? Epsilon means no 0 even, 0 odd.
Yes, sir.
Definitely both are even. So this would be my start state. Am I right?
Yes, sir.
Now, epsilon, if I get a 0, how many 0 would be there? 0. So how many 0 is there? 1. How many 1 are there? 0. So which state I would go?
Huh?
Which state I would go? From epsilon. In epsilon, I'm in this state. That means 0 number of 0 and 0 number of 1. After that one, I suddenly get 1 0. So new string is 0. So
Yes,
how
sir.
many zeros are there?
1.
How many ones are there?
Sir, 0.
So which state I should go from here to?
OE. OE.
OE. Okay.
Zero.
OE. OE. On the other hand, from this state, if I get 1, my new string is 1. So here I have 0 number of even, 1 number of 1. So which state I should go?
EO.
EO. Fine. This one is done. Let's go to this one. So we go here by seeing 0. If I get another 0, then my new string is 0 0, which means 2 0 and 0 1. So which state I should go?
So initial state, EE.
I will come back to initial state. After getting 0, if I get a 1, my new string would be 0 1. So 1 1 0 1 1. So which state I should go?
Sir, EO.
Why EO?
No, sir. No, sir. No, sir.
Odd 0, odd 1. So I should. Alright, guys. So we are done with this. Let's go back to here. Here we come from seeing 1. If I see another 0, it becomes 1 0. So 1 1 0 and 1 1. So oh. Here if I get another 1, this become 1 1. So 0 0 0 0 number of 0 and 2 number of 1. So which state I should go?
EE.
EE. So we are done with this. Let's go to here. We come here seeing 1 0 1 0 or 0 1. So let's take only 1 1 0. If I get another 0, it becomes 1 0 0. So 2 0 1 1. So which state I should go? 0 is even, 1 is odd. So 0 is even, 1 is odd. So I should go back to this state. And here if I get a 1, it becomes 1 0 1. 0 1 0 2 1. So 0 is odd and 1 is even. So I will go. Then it is also done. Which one would be the final state? Which one would be the final state?
Full state or final state?
Sir, EO.
EO, because even number of 0. So EO, so this one.
Sir,
Did you understand? Even number of 0, odd number of 1. So this one is even, this one is should be.
Achha.
This one is even. Is this problem clear to you guys?
Yes, sir.
Yes, sir.
Is there any other technique you can solve this problem? This is one of the techniques. Try to come up with an algorithm based on skeleton, then make up the skeleton. It is one of the technique. Is there any other technique? How many parts in this language? In this language, how many parts? One part is even number of 0. Another part is odd number of 1. So it is actually joining of two finite automata. Am I right or not?
Yes, sir.
So let's start with first finite automata. How can you solve the first finite automata? Even number of 0. How can you solve this? Huh? So L is nothing but L1. Let's assume L1 is even number of 0. So how can you solve this one? What would be the algorithm for this? Even number of 0. How can you solve this?
Number থাকবে একটা odd.
So we can consider this one is even, this one is odd. After seeing, so after epsilon, if you see as many 0 as I want, I will be still in even. If I see a 1, I'm in the odd state. Then afterwards, if I see a 0, I'm again in the even state. If I get here 1, still I'm in the odd state. Which one is the final state? This one. Let's consider this A, let's consider this B. So what is Q1? A comma B. Right? Right, guys?
Yes, sir.
Okay. Now what is L2? Odd number of 1. So what will be this one? Same type of finite automata, but this is also even, this is also odd. But in this case, we're counting number of 1. So initially, is it correct or not? Made a mistake here. Now it is correct. Am I right? I made a mistake. I'm counting 0
Yes,
here.
sir.
How about this? Epsilon is even. If I get 1, then it is odd. After get back 1, it is again. So this one is final state. 0 is not. So let's call this CD. Q2 is nothing but C comma D. Now, what would be the solution? The language L. L1 and L2. Both should be there. So how can you solve this one? How can I solve this one?
Finding an
So
intersection.
how many states? How many states should be there? L1 has Q1 states. L2 has Q2. Both is present. So it is nothing but cross product. Am I right?
Yes, sir.
So what would be the state for Q? AC, AD, BC, BD. Am I right? A, C, A, D, B, C, B, D. Am I right? So
Yes,
this
sir.
is actually L1, this is actually L2. L is nothing but L1 and L2 both. This one is true and this one is also true. So we can do the Cartesian product and get the four steps. So we can draw this one. This is nothing but SC. This is nothing but BC. This is nothing but AD. This is nothing but BD. Now again do the same thing. A seeing 0, why should it go? B and C seeing 0, why should it go? A seeing 0, why should it go?
B.
C seeing 0, why should it go?
C.
AC seeing 0, why should it go?
BC.
Now A seeing 1, why should it go? A. C seeing 1, why should it go?
D.
D. So AC seeing 1 should go to AD. Did you get it? Now fill up the rest of this. Then
Yes, sir.
B seeing 0, why should it go?
A.
Back to A. C seeing 0, why should it go?
C.
C. So BC seeing 0 should go back to A. SC. Now B seeing 1, why should it go? B. C
B.
seeing 1, why should it go? D. So BC seeing 1 should go to BD. So we are done with this. Now let's take this. B seeing 0, why should it go? A. And D seeing 0, why should it go? D. So BD seeing 0 should come back to AD. B seeing 1, why should it go? B. D seeing 1, why should it go? C. So BD seeing 1 should go to BC. So we are done with this. Now A seeing 0, why should it go? B. Now D seeing 0, why should it go? D. So AD seeing 0 should go back to BD. And final one, A seeing 1, why should it go? A. And D seeing 1, why should it go?
C.
So AD seeing 1 should go to BC. So what would be the final state? Here the final state is A, here the final state is D. So when we do the Cartesian product, we'll study more. Then Cartesian product of two finite automata always have the final state of both. So AD is the final state. So this one is the final state. So did you get it? So the previous one and this one, they are absolutely same. Same finite automata. They don't have any difference. If you put instead of A, E, and instead of C, E, and here instead of B, 0, and instead of D, 0, you will get the same one. Okay? So they are same, identical, but two different ways we have solved. Do you have any more questions? Which one is easy actually?
This one.
Second one.
Yes, sir.
Second one is easy.
Second one is Cartesian product. It will take time. Okay. First one is drawing skeleton and solve the problem. Do you have any question? We'll stop here today. You people most probably have class on Thursday. Am I right?
Yes, sir.
Yes, sir.
So you people are already ahead in one class. Okay. So Thursday we'll take another class. So you people get in much advance. Any more question, please?
No, sir.
So let's take the attendance. Am I right?
Yes, sir. স্যার লাস্ট ক্লাসে স্যার অনেকে স্যার প্রেজেন্ট থাকা সত্ত্বেও অ্যাবসেন্ট এসেছে স্যার
Then ওটা হয়তো সিস্টেমের প্রবলেম. Forget about the system.
ওকে
So there is no marks. There is no marks in attendance, and this semester there is no auto withdrawal. Do you know that?
ইয়েস
And only you can self withdraw if you don't want to continue the class. That is possible. and the last date of self withdrawal is September 3. Please remember the date. Okay. All right, guys. Should we stop here today?
Sure, sir.
Yes, sir.
Is today's topics clear to you guys?
Yes,
Yes,
sir.
sir.
Finite automata is very fun. It is a funny topic. Am I right? If you pay little attention, it is really funny. Am I right?
Yes,
Okay. So let's stop here today. See you then next class. Bye.
স্যার একটা রিকোয়েস্ট ছিল
Yes, please.
অনেক সময় স্ট্রিমের কোয়ালিটিটা ডিপ করেছে সো ইট ওয়াজ হার্ড টু ফলো হোয়াট ইউ আর রাইটিং ক্যান ইউ টেক পিকচার্স অফ দ্য পেজেস এন্ড আপলোড দেম
I always do that one. If you go to Piazza account, all the images of my lecture notes are there.
আচ্ছা ঠিক আছে স্যার
So I can give you one advice. Why don't you print those images and then again listen the video, just keeping in front of you those pages. Then it would become very easy. Okay?
জি স্যার ওইটাই করবো এখন
Okay, okay. Thank you very much. Take care.
Thank you, sir.
Bye.
Awesome.
Thank you, sir.
So